Hello students, here is Marisha. Today we are going to study about resource allocation graph. Let's see who is driven by the resource allocation graph. That is nothing but the graphical representation of the state of system. Let's see, for example, we have allocated one printer, right? And printer, that is the resource, and whatever we are printing, that is the process, right? So one process is allocated to another resource. Then how we represent this in a graphical way? So this is about the resource allocation graph. Let's see, resource allocation graph is graphical, or you can say pictorial, or pictorial representation of states of system. So this is the definition of resource allocation graph. See, process is denoted by circle, okay, and resource is denoted by rectangle. Whenever we are showing the process, then we have to denote by the like this, and where we are discussing about the resource, then we have to represent it like this, right? In simple terms, resource allocation graph, we can say that is a RAG. In short, we can also say that RAG, resource allocation graph, right? Next, what do you mean by the resource allocation graph? We can say it is a set of V vertices and E edges. Okay, so it is nothing but the set of vertices and edges. Okay, but let's see, vertices are divided into the two parts. Okay, one, that is a process, and second, that is resource. So P denote by, it's a set of process P1, P2 up to Pn. The terms of, we can say that is a set of processes. Okay, and what's about the R resource? That is a collection of resource, set of resources. So this is nothing but a resource allocation graph, right? Resource allocation graph, let's take one example. We have three processes, P1, P2 and P3. These are the processes. And we have the resource like R1, R2, R3 and R4. These are the resources. These are the processes and these are the resources. If suppose P1 process is there, P2 process is there and P3 process is there. So processes we have already seen, that is denoted by the circle. So we have drawn here the P1, P2 and P3 like this. Okay. Next, we have resources like whenever, if suppose this process is request to this, ages mainly, these are the vertices, these are the ages. So ages can be defined like a request. That means P process request to resource. Okay, whenever a process requesting to resource, that is called as a request ages. Okay, and assigning age is there. So assigning ages means what? Resource is using this process is using the resource. That means this resource is already allocated to process. So mind that there's 2 points. Whenever the process requesting to resource, then this type of the ages we have to use P1, PI request to object. Okay, and assigning ages, that means resource is allocated to PI. Let's see, one P1 process is request to R1. This ages is called as a request ages. But R1 process is already allocated to this process. This process, this resource is already allocated to P3. Then this ages is called assigning ages. Same as it is here, R3 resource is allocated to P1. So again, that is called as a assign ages. Okay, and P2 process request to R2. P2 process request to R2. Okay, so this is called as a request ages. But for suppose R2 is allocated to any other process, then this is called as a assigning ages. So this is how the resource allocation graph. We have to keep in mind are only the vertices and ages. Vertices is divided into the 2 parts, that is the process and resource. Right? Process is denoted by circle and resource, that is denoted by the rectangle. Right? Whenever we are going to represent any resource allocation graph, then keep in mind about the ages. First, request ages, and second, assigning ages. Request ages means what? Whenever the process requesting to any resource, then we have to use the request ages, and already resource allocated to any process, then we have to use the assigning ages. Okay, so this is about the resource allocation graph. Let's see one example of resource allocation graph. That is like we have to print some documents, right? We have to print some documents. So we need what? Printer. That is our resource. And some processes are there. P1, P2 and P3. Right? So here P1 process is there. P1 process is requesting to print the printer. Is requesting to the printer. Right? So, but this printer is allocated to any other process, P2. So this is called as a and this is called as assigning ages. That means we can say that P1 has to wait. P1 has to wait until P2 release this resource. Okay, so P1 requesting R1. R1 is already allocated to another process, that is P2. Whenever P2 released it, then this is maybe allocated to P1. So this kind of example we have to see. The real time example is there, but later on we can understand in the deadlock how to resource allocation graph is used mainly. Okay, so again you have to keep in mind only process is denoted by circle, resources allocated by rectangle, resource allocation graph, that is nothing but the set of the vertices and edges, right? Vertices is nothing but the set of processes and resource. P, that is denoted by the process, and R is denoted to the resource. R stands for resource, P stands for process, right? And this is the way how you allocate it to the process and resource. Hope you understand this. Let's next topic is, let's see some another examples of resource allocation graph. For example, let's see P1, P2 and P3 processes are there, and here R1, R2 and R3 processes are there. Okay, so P1 request to R1, P1 request to R1. Okay, but R1 is allocated to P2. P2 is requesting to R2, but R2 is allocated to P3, and P3 is requesting to R2. So let's see, when P1 process request to R1, right? R1 is allocated to P2. P2 is requesting to R2, and R2 is allocated to P3, and P3 is requesting to R3. But let's see that some are the instance 1, 1, 1, 2, 3. So this is showing like only one process. Only one process can use this resource at a time. Okay? Same as it is only one process. Okay? And here may be possible 3 process can be used this resource. So these are called as instance. These are called as instance. Let's see another example of this. P1 process is there, P2 process is there, and P3 process is there. Okay, and resource R1, R2 and R3. We have to denote the instance. So here 1 instance, here 3 instance, and here 2 instance. Okay, so P1 requesting to R1. R1 is already allocated to P2, and P2 is requesting to R2, right? But R2 is allocated to P3. P3 there, two instances are there, and we can denote like this. Okay, so here the two instances are there. That means at a time two processes can use it. Let's see another process like this, P4 or P5. We can write like this. Okay, but let's see. P1 is requesting to R1. R1 is allocated to P2. P2 is requesting to R2. R2 is already allocated to P3. P3 is requesting to R3. R3 is already allocated to P1 and P4. It may be possible here the two instances are there, right? So another process we can write down P5. So see, here to here, 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 here. That is called as a closed path, we can say, or we can say cycle, right? Whenever you are showing like this, then it may be possible in that block. We will see later exactly in detail what do you mean by the deadlock. But this is we call as a deadlock. See, in short we can say when the resource is allocated to any process and another process has to wait indefinitely, like infinitively. That means this resource may not allocated to that process, then this situation is called as deadlock. Understood? Okay? Simple example, in real time example we can consider like this. See, these are the students P1, P2 and P3. Okay? And these are the assignments. Okay? 1, 2 and 3. Okay? So, these students is requesting for the assignment 1. Okay? But assignment 1 that is already accessed by the another student. Okay? So, this process has to wait until it is not released this assignment. As well as P2 is requesting for the another assignment, but this assignment is also allocated to another. So this process has to wait. But when it is finished, we don't know. Whenever the process releases this assignment, then another process can use. So this whole situation, we can say that is that. Okay, we will see later. But this is whenever the closed path or cycle arise, then deadlock may be possible. If suppose this is not happening, this is allocated to any other process P6. Let's see. Here 2, here, this is requesting to this see, R1 is allocated to P2, P2 is requesting to R2, R2 is allocated to P3, P3 requesting to R3, no. Is there any closed path? Let's see. Here to here, here to here, here to here. So, no. So, this condition is not occurring with that. Okay? This is called as a resource allocation graph. Hope you understand the resource allocation graph, like instance, resource and process. Okay? So this is about the resource allocation graph. We will see later what does it mean at block. Next topic is that